So in this short video, we're going to have a look at defining pH and using it in some very simple pH calculations. So pH is mathematically defined as being the negative log to base 10 of the hydrogen ion concentration. Now, those of you that don't do A-level maths are probably looking at that and freaking out, but I just want you to know it is a button on your calculator. You don't need to fully understand what it means, but I would have a play with it and have a play with using log and different numbers and see if you can kind of in your head work out what a log to base 10 is. The inverse of a log to base 10 is to do 10 to the power of. So if you want to work out the hydrogen ion concentration, you do 10 to the minus the pH. Now, let's see how this works out in calculations. So if we have a strong monoprotic acid, now you might be going, what's monoprotic? Well, mono means one, as in monocle, monorail. So HCl or HNO3, hydrochloric or nitric acid, both have one proton per molecule. So they are monoprotic acids. They are strong acids, which actually means that when we dissolve them in water, so let's take the example of hydrochloric. So when we put hydrochloric acid into water, then we get full dissociation. So the whole of the hydrochloric acid, because chloride ions are very, very stable and happy on their own in water, then we get full dissociation. So we don't draw an equilibrium sign here because the reaction goes to completion. So it's written as H3O plus and Cl minus, but we can simplify it just as being it turns into H plus and Cl minus if we miss out the water. So that's this is the simplified equation. So looking at that, because it's a full reaction, it goes to completion, it doesn't form an equilibrium, we know that our hydrogen ion concentration is equivalent to the hydrochloric acid concentration. 1 mole of hydrochloric acid produces 1 mole of hydrogen ions. So therefore, all we need to do to work it out is to use pH equals negative log to base 10 of the hydrogen ion concentration. So if we were using 0.01 moles per decimetre cubed hydrochloric acid, we can work the pH out because we know that the acid concentration is equal to the hydrogen ion concentration. So if we plug into our calculator log to base 10 of 0.01, it will come out with an answer of -2, but we do the minus of it, so the answer is 2. So the pH is negative log to base 10 of 0.01, which comes out as 2. If we consider the nitric acid then, so same sort of thing, we can draw out the full equation when it gets dissolved in water. We get the oxonium ion and the nitrate ion, which would be the conjugate base. But then we can simplify that because we don't always want to write out the water. We know it's there, but we don't have to write it all the time. We can just write it as it forms a proton and a nitrate ion. Again, it's strong, it's monoprotic, so we know that our concentration of hydrogen ions is equal to our concentration of the acid that we put in at the start. There's no equilibrium, so 1 mole of nitric acid forms 1 mole of hydrogen ions. So if we are given a question that it says, so what is the concentration if the pH is whatever? So our question is, what is the concentration of nitric acid if the pH is 3.6? So to work out the concentration, we just need to, because they're one and the so it's 1 to 1. So our concentration is going to be equal to 10 to the minus 3.6. And again, you can plug that into your calculator. Make sure you're using a scientific calculator and make sure you know how to use it for these. That comes out as 0.00025 or 2.5 times 10 to the minus 4. So let's look now at some slightly, well, still very simple pH calculations, but slightly more complicated. This time we're going to look at a diprotic acid. So I hope by now you've kind of realised that a diprotic acid is going to be one that's got two hydrogen ions that dissociate. So for example, sulfuric acid, which is H2SO4. So if we write out the equation for the dissociation, H2SO4 will react with water and we're going to need 2 molecules of water per H2SO4 because for every molecule of sulfuric acid we're going to get 2 oxonium ions as well as our conjugate base, our sulfate ion. You'll notice again it's just a straightforward arrow, it's not an equilibrium, this is a strong acid, it fully ionises or fully dissociates. We can simplify that just as writing H2SO4 turns into 2H plus SO4 2 minus. Now we can see our relationship now is 1 to 2, so the concentration of the sulfuric acid is going to be half the concentration of the number of hydrogen ions. So if I say what is the pH of 0.01 moles per decimetre cubed sulfuric acid, you might want to press pause and see if you can work it out quickly. Right, so if our hydrogen ion concentration is going to be equal to two lots of our sulfuric acid concentration, so it's going to be twice the sulfuric acid concentration. Therefore, our pH is going to be negative log to base 10. I hope you've got the hang of where these buttons are on your calculator by now. Of our hydrogen ion concentration, which isn't 0.01, it's going to be 0.02. And that comes out as, you plug that into the calculator, it's 1.689 or something, so 1.7 rounded up. Just do one more final example for you. So let's look at working out the concentration of the sulfuric acid from the pH. So we're going to use 10 to the minus pH for this. So what is the concentration of the sulfuric acid if the pH is... I can't remember what I put when I did the drawing part. So concentration with a pH of 4. Hopefully you'd be using a digital pH meter and it'd give it to you to 2 decimal places rather than just 4, but we can work this out. So if the pH is 4, then the hydrogen ion concentration is going to be 10 to the minus 4. And the sulfuric acid concentration okay, so that's 10 to the minus 4. So our sulfuric acid concentration is going to be half of that because of the 1 to 2 relationship between the acid and the hydrogen ions. So it's going to be 0.00005 or 5 times 10 to the minus 5.